Screen is visible?
Yes, sir.
Yes.
Yes. Yesterday we started with the day before yesterday. Uh, 1 minute. So we started with the even function. We understood what the even and odd functions are there. In case of even function, the graph is symmetric about graph of the function is symmetric about y-axis, whereas in case of odd function, the graph of function is symmetric in opposite quadrant. Okay. Then we studied the integral property. In case of odd function, if f of x is odd, integral of f of x dx equal to 0 when limits are from minus a to a. Lower and upper limit are same except the sign. Whereas in case of even function, the answer will be 2 times, and now we have to take the limits from 0 to a only. Okay, then we understood what is product, division, addition, and subtraction of the even and odd function is. Then uh, we gone through few examples also, right? This example is particularly important that we studied here. F of x equal to 1 plus x and 1 minus x when it is defined from minus 1 to 0 and 0 to 1 respectively. Then the conclusion was that the function is even, and geometrically also we try to understood it. Okay. Then we know what the Fourier series is, and then we obtained the Fourier series for even function, and the resultant was like this: if Fourier series, sorry, the Fourier series expansion of a function f of x, which is even, and which is defined from minus L to L is f of x equal to a naught by 2 plus summation a n cos of n pi x divided by n, where a naught is 2 by n, integration from 0 to L f of x dx, whereas a n equal to 2 by L, integration from 0 to L f of x cos of n pi x divided by n dx. X is not evident here, it is x should be there. Then Fourier series expansion of odd function is given by summation of bn sine of n pi x divided by l, where bn equal to 2 by n, integration from 0 to l f of x sine of n pi x divided by n dx. Then I think we solve one example. This was the example. We obtain a n. What about bn? Have we obtained the bn?
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
Bn is
Yes.
Yes, sir. 4 by pi n.
4 upon n pi.
4 upon pi n.
4 by n pi. No, no.
4 by n pi.
4 by n pi. This is the bn.
सर एक डाउट
Okay.
था.
Just 1 minute. What was the an?
Sir, a n minus 4
Minus
by
4
square
upon
square.
n cube
4 by
pi
n
cube.
square pi square.
N square pi
And
cube.
what about a naught?
16 by 3.
16 by 3. Yes. What the doubt is?
If function neither even nor odd तो तीनों calculate करने ना.
In that case, we have to find a naught, a and b and all the three we want to obtain.
Okay.
Okay. Thus, you write this, thus Fourier series expansion of given function is f of x equal to a naught by 2 plus summation n cos of n pi x divided by L, but L is 1 here, plus bn sine of n pi x divided by 1, n equal to 1 to infinity. So here our answer is like this: f of x equal to 16 by 3 divided by 2. So it is 8 by 3. Hope this is clear. Now say this is the Fourier series expansion.
Yes, sir.
Now we can expand it in this way: 8 by 3 plus, now when n equal to 1, we have like this, minus 4 divided by pi square cos of pi x plus 4 by pi sine of pi x. Okay, when n equal to 2, so minus 4 divided by n square, na? So n is 2 square, so 4 pi square cos of 2 pi x plus 4 divided by 2 pi sine of 2 pi x. This is for n equal to 2. Now, if we take n equal to 3, the next term will be like this, minus 4 divided by 3 square, so 9 pi square cos of 3 pi x plus 4 by 3 pi sine of 3 pi x, and now so on, n equal to 4, n equal to 5, and so on. This is actual Fourier series expansion of the function f of x. Right? In exam, you don't have to write this, but this should be known to us. In exam, what you have to write? Writing up to this step will be sufficient.
Yes.
This will be sufficient. Okay. Now we have to understand what we are doing exactly. Okay. So let me go to the next page. Written everything?
Sir, in exam, what can they ask?
Now, if it is online exam, then it will ask what is the value of A naught. So just you have to find A naught only. Or it may be asked what is A1 only. Usually AN will be not asked. What is A1 or what is B1 only. So while writing the formula, there only after writing the AN, you take n equal to 1. So the integral will be simplified. Okay?
Yes, sir.
Can I go to the next page now?
Yes, sir.
Yes, sir.
Acha, what is the function where we started? Whose Fourier series
4
we
minus
have?
x.
F
4
of
minus
equal
x square.
f of x equal to 4 minus x square, and then interval of, sorry. I forget to change the page. F of x equal to 4 minus x square, and interval was x between 0 to 0 to 2, right? So I think you understand this. This is y equal to 4 minus x square, or in other words, can we write like this? X square equal to 4 minus y.
So graphically.
Graphically, how it will be?
So it's parabola.
Parabola. Okay.
X
Then
square is equal to 4ay. Oh.
powers of x are even, so symmetric about y-axis. So if you take x equal to 0, y equal to 4, x-axis, y-axis. So say this is 2, this is 4, y equal to, I'm saying, 6, 8, 10, and so on. This is 0. This is x equal to, say, 1, 2, 3, 4, and so on. Minus 1, minus 2, minus 3, and so on. So parabola is like this. Right? But again, passing through the 4. Again, we are not considering this part. We are considering parabola from 0 to 2 only, x equal to 0 to x equal to 2 only. In fact, this part of parabola only. Understood geometrically?
Yes.
Okay. I do understand. At this moment, it is difficult to understand this in this form. So let me make small modification. Let me shift the x-axis. So I'm considering it in this way. Let me take a bigger diagram. So this is
Sir, it would be inverted parabola.
no. Huh? Inverted parabola. Since it is negative.
Yes, sir.
Absolutely.
Yes, sir. Y minus 4. So
It should be
minus
like
1.
this. It should be like this. Yes, no doubt. So this part of parabola we have to take. Okay. So this is y equal to 4. So this is the point 0, 4. So we have this parabola. X equal to 2 here. X equal to 1 here. X equal to 0 here. This is given function. Right? Then it is periodic. Therefore, if we try to draw it from x equal to 2 to x equal to 4, then it will be like this. Okay, so I'm not considering that part. Now see, try to understand meaning of what we are doing. So on the previous page, we have taken n equal to 1, n equal to 2, n equal to 3 like this. Huh? Okay, so say when we take n equal to 1, and if we write the f of x will be 8 by 3 and the first term corresponding to n equal to 1. Okay, I'm ignoring the remaining terms. I'm not considering the remaining terms. Then the graph will be, for example, like this. This will be the Fourier series representation. If we try to draw the graph, if we take n equal to 2, so f of x will be equal to 8 by 3 plus first term and second term. And then we are ignoring remaining terms. Then in that case, graph may be like this. Near to it, okay? Now when n equal to 10, the graph may be like this. When n equal to 10, graph is like this. And when n equal to 100, again I am saying for example, when n equal to 100, the graph will be like this.
It gets compressive.
And when n equal to infinity, we'll get this red color line, the actual graph. Getting everyone? This is what we are doing using the Fourier series expansion. Hope it is clear. If it is not clear, what we can do sometime, at this moment it is not possible, using some mathematical software. You might know the different mathematical software. Mathematica is there, MATLAB is there. Okay, so I'll try to see whether it is possible to use this software and try to understand this, but not now, afterwards. Okay, give me some time for that, since at this moment I'm busy in other work also. Okay, yes, let me continue. Let me continue with the next example. Any doubt till? Understood what we are doing exactly? We are approximating the function. Which function? A function which is periodic function and which satisfy the Dirichlet's condition. And how we are approximating? Two different questions are there. What we are approximating? A function. Which function? A function which is periodic and which satisfy Dirichlet's condition. This is the first. Second, how we are approximating? We are approximating it by a Fourier series expansion. That is, we are writing the function in terms of standard periodic function sine x and cos x. Clear?
Yes,
Okay.
sir.
And how it looks? It looks whatever we have shown in the figure before some time. When n equal to 1, we'll get the blue line. When n equal to 2, we'll get the blue curve. Sorry, it is not line. Then when n equal to 2, we'll get the green curve. When n equal to say 10, we'll get the yellow curve. And when n equal to say 100, again I'm saying for example, n equal to 100, we'll get the exact curve. Okay, like this. Clear?
Yes,
Now
sir.
let me continue with the next example. Find Fourier. Let me change the page. Okay, so example is like this. Second example. Find Fourier series expansion of f of x equal to . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . and hence obtain sum of this series. Okay, so done. Solution.
A1 function.
Yes. Replacing x by minus x. Already we studied this example, but till if it is not clear, we'll do it once again. We'll do the whole procedure once again. I have replaced x by minus x. Huh? Change in x only. X is replaced by minus x. Multiply inequalities by minus 1. Inequalities will change. Sorry, this will become plus, this will become minus. Yes, now compare. So comparison is like this. X between 0 to 1. 1 minus x. See the function. X between 0 to 1.
Yes, sir.
1
Equal.
minus x. Same. Okay. Now,
Yes.
x between minus 1 to 0. 1 plus x. Here also it is 1
Same.
plus x. So it is equal to f of x. F of x is
Even.
Bn will be 0, no?
absolutely. F of x is even function. Clear?
Yes.
Yes, sir.
Okay.
Yes, sir.
Okay, Radha. Therefore, n by x divided by here. What is length of interval? Minus 1 to 1 now. Function is defined from minus 1 to 1.
2.
So two.
Yes. So L is 1. So f of x equal to. Right formula of a naught. Even function, so it is not 1 by L. It is 2 by L and half of the limit 0 to L. Now very important question. Which part of function is to be considered? F of x is written now, but two parts of functions are there. One is 1 plus x and other is 1 minus x. So see the limits.
1 minus.
कोई भी करना सर, दोनों तीन रहने वाले.
No. You cannot take any part. you have to take a
minus x.
particular part only. So limits are from 0 to right. I'll write this. Limits are from 0 to 1. So f of x equal to, what is value of f of x in 0 to 1? 1 minus
plus
x. Na? So we have to
0
take
to
that part
1.
only. We
Yes,
cannot
sir.
take 1 plus x, isn't it? Getting everyone? So we have to take that part only. Okay, so take that part. So 2, then it is 1 minus x dx. Now integrate. Now it's not a difficult part.
नहीं सर, वैसे नहीं सर, अगर हमने 1 प्लस एक्स लिया तो लिमिट -1 to 0 कर देंगे ना.
हाँ, that is okay. That is
नहीं,
okay.
वो गलत है.
Okay, no problem. No problem. So I think it is 1.
Yes, sir.
Yes.
Yes, sir.
I will go to the next page. Yes. Now we have to find an. Do it yourself. See whether you are able to find an. So can I change the page? Let me change it. Two by L. So now we have to use the by parts formula. Yes, let me use this formula. U as it is, integration of the V.
Cos n pi x upon n pi.
Just 1 minute.
First term will 0 will come.
0. Lower limit, sine of 0, 0. Cos of 0, 1. So it is, I have to use a formula. So I'll mention it here. Here only. What is cos of n pi?
-1.
-1 raised to n.
Absolutely. Use that. Mute yourself. Yes, this is an. Okay, now we have to substitute all the values in equation number 1 first. Complete it. Any doubt? Any doubt in any step?
No, sir.
Any doubt? If any doubt is there, not understood any step, let me know. If understood, we can proceed.
Understood, sir.
Yes.
Understood, sir.
Okay. Now we'll go to the next page. So, let me change the page. Now, substituting values in 1. So, 1 is what? Of x equal to a naught by 2 plus summation n cos of n pi x n equal to 1 to infinity. So a naught is 1.
Half.
Yes. And n we obtained before some time, that is 2 divided by n square pi square 1 minus 1 raised to n. Final answer is Fourier series expansion is like this. See, from this summation, n is the variable, n equal to 1 to infinity is written. Na? So remaining things, they are the
Pi square.
constant. So 2 by pi square is constant. Yes, n equal to 1 to infinity. 1 minus of minus 1 raised to n divided by n square. Cos of n pi x. This is the answer. This is the Fourier series expansion.
Yes, sir.
So in this way, we have to find the Fourier series expansion. Okay. We go through next table. We find first complete it. Written everything. Okay, fine. Fourier series expansion of.
So that sum of series.
That is not required. You have to write up to this only.
Okay, sir.
That way written to understand what we are doing exactly.
Yes.
Okay. So find Acha, sorry. That you are saying. Sorry.
Sir, 1 by 1 plus 3 square.
Absolutely. That is required. Okay. That is required. Okay, no problem. Where I can write it, I can start from here only. Actually, okay, no problem. So, Madam, f of x equal to second part is remaining. We want to find the sum of series. So, substitute the value of f of x. What the f of x was?
1 minus x.
1 minus f of x.
Yes, 1 minus x.
1 minus x.
Achha, that function f of x. Two parts were there, na?
Yes, sir.
So let me keep f of x as it is. 1 upon 2 plus 2 by pi square. Okay, now take n equal to 1. See what happens. In the summation, now 1 minus 1 raised to n is there. No? You take n equal to 1.
0.
So if you take n equal to 1, so minus 1 raised to 1 is minus 1. Why 0?
2 by n square.
2 by n square. 2 by n square.
Minus 1. So minus minus plus. So 2 by n square.
2 only. N clearly we have taken 1, no?
And we have taken 1. Absolutely. 2 by 1 square. And then cos of pi x. N equal to 1.
Yes.
Cos of pi x. So now value of cos pi x depends upon x. Okay. Plus. Now take n equal to 2. So this is when n equal to 1. Take n equal
0.
to 2.
It will become 0.
Yes.
0.
Minus 1 raised to 2 is plus 1. Minus 1 plus 1, 0. So n equal to 2 will get 0. Plus.
Even
Now
power
take
of
n equal to 3.
0.
N equal to 3. So it will be 2 divided by 3 square, isn't it?
Yes.
And cos of 3 pi x plus n equal to 4.
0.
Absolutely. Then n equal to 5.
2
So
by 5
2
square.
divided by
Cos
5
5
square
pi x.
cos of 5 pi
5 pi x.
x, and now so on. Okay, so I'll write it once again so that there will be no any confusion. I do understand it is repetition, but let me write it once again. 1 upon 2 plus 2 divided by pi square, and we have 2 divided by 1 square cos of pi x plus 2 divided by 3 square cos of 3 pi x plus 2 divided by 5 square cos of 5 pi x, and now so on. Now tell me, what should be value of x so that
Minus 1.
we will get
Minus
that
1.
ordered term. X, value of x we want. Yes, what should be x? Understand my question. See,
0.
somehow we should able to find this series. 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square. This is what we want.
Sir, it is included in this. बाकी सब कट नहीं होना चाहिए ना?
We'll see about remaining terms. At least see, you might have understood, you might have observed that what we want this term, right, equal to 1. This term equal to some number, right? Equal number. Maybe 1, maybe minus 1, maybe 3, maybe 5, maybe 10. We don't have any problem.
So x is 0, sir.
0, 1, minus 1. तीनों में से कोई भी चलेगा सर.
Minus
Sir,
1
0
चलेगा.
Minus 1, minus pi, minus 2 pi आ जाएंगे ना.
अच्छा सर, माइनस आ जाएगा. चलो, so we'll start with the simplest value, x equal to 0. This is again trial and error method. Let us start with x equal to 0 and we'll see what happens. Okay, so now f of 0 now equal to 1 upon 2 plus 2 by pi square, right, cos of 0. So that everyone understand, I'm writing more step usually. So those who understand, they can skip these steps. Those who are getting it, they can skip this step. I have to take care of each and every student. So usually I write more steps. Okay. So f of 0, 1 upon 2 plus 2 divided by pi square. Cos of 0 is 1. So 2 divided by 1 square plus 2 divided by 3 square plus 2 divided by 5 square, and now so on. Now I have to go to the next page. I'll continue with this expression. Let me write this as expression number 2. Okay. Can I go to the next page?
Yes, sir.
Hope everyone is getting this. Okay, so I'll change the page. I think there are only few students, those who used to speak. Those who are not getting it, please let me know. so that if required I can take more examples. This may be the one way. If required we can have if required we can have more examples. I can decrease the speed. Right, this is the function that we have. Now we have to find f of 0. So how we can find f of 0? You take any value, maybe 1 plus x or 1 minus x, and you find its value at 0. Both of them are equal only.
1.
Right now, f of 0 equal to 1. Since equal to 0 is there in both the case, therefore we can take any value. Whether you take 1 plus x at x equal to 0 or 1 minus x at x equal to 0, it is 1 only. One equal to f of 0 equal to half plus 2 by pi square, and then required infinite series. I think 2 is there. Now simple part, huh? 1 minus half, 2 is taken outside. So
pi square by 8.
yes, sum of the series is pi square by 8. So this is one of the application of Fourier series. We can find sum of few of the series. Those who are interested in mathematics, you take different values of x equal to pi by 2 in the Fourier series expansion. You take x equal to pi and see what different series we are getting. Clear? Understood? Now we'll go through the next example. Find any doubt in previous example? F of x equal to x between minus 3 to plus 3. Sarana, solution. What is midpoint? I
0.
think everyone know how to find the midpoint, huh?
Yes, sir.
Everyone know how to find the midpoint?
Yes.
Terminal point minus initial. How to find midpoint? Plus.
We have to do plus.
Divided by 2. So it is 0.
Yes, sir.
But either is evident from minus 3 to 3 only. Okay. So f of x is what type of function?
Odd. Odd function, sir.
Yes. Then around period equal to 2l, and what is length of the interval? 6.
6.
Therefore, what the l is? 3.
3.
Okay. Then that Fourier series expansion is. So, what is Fourier series expansion of odd function? Write it.
Only bn sine.
Yes, bn
Bn sine
sin
n
n
by x
by
up
x
n.
divided by l.
L.
But l is known to us. L is 3. So now we'll find Bn on the next page. Right, Bn equal to, fast now. How much time we have still? 11:30. Can I change the page?
Yes, sir.
Yes, sir.
Yes. So let Bn equal to
2 by L.
absolutely.
Sin n pi x upon L.
L.
L is known to us.
Is
F of x is also known to us.
10 by UV.
Yes, absolutely. Bernoulli's formula. N square pi square 9. Next term is 0. So it is this is not x. Minus minus plus. Upper limit. N equal to 3. Lower limit. Sin of 0 equal to 0, therefore 0. Then we know this very well. Sin of n pi equal to 0.
0.
Cos of n pi equal to minus 1 raised to n.
Bn is equal to minus 6 bracket मध्ये minus 1 raised to n upon.
Absolutely. Absolutely. Like this.
Yes, sir.
Yes, sir.
Yes, sir.
Now substitute that in equation number 1. That's it. This is the Fourier series expansion. Hope you might have understood it. Some homework will be given And how much time you want to complete the homework? Yes.
After unit test.
Sir, unit test के बाद.
Next Monday is okay?
नेक्स्ट मंडे सर, नेक्स्ट मंडे से यूनिट टेस्ट चालू हो रहा है ना सर?
Sorry, next to next Monday.
यस सर.
Yes, sir.
Okay.
Whatever the homework will be
Okay,
given
sir.
in, no problem. Whatever homework will be given today and in next week, for all the homework deadline will be next to next Monday. Okay?
Yes sir.
Yes, sir.
I think that will be better, so that you will not have any burden. Okay, no problem. All the best for exam. MCQs I am posting
Thank you, sir.
today. I have posted the notes yesterday. Video lectures I will post today. Whatever remaining, I will post everything today. If anything is remaining, you can send the message to me on WhatsApp. It will be better if you send the message to me now only, since for last 1 week I am not well, and I have taken leaves CL on many of the days. So today also I am not feeling well. Maybe in afternoon I have to leave. Okay. So all the best for your exam. Okay.
Thank you sir.
Chalo, bye bye bye.
Bye
Thank you,
sir.
sir. Bye.
Present.
Thank you, sir.
Sir present.
Present एक minute. How many are present? 66. हाँ ठीक है. No problem. Everyone is present, then there is no any problem.
So for exam, you test the portion is still here only, no?
हाँ